So here's the thing. Today, we're learning about
Greatest common factor?
greatest
Got it.
common factor.
Oh, I remember this.
Okay, now the problem with this is that the next thing we're going to learn is least common multiple. All right? The two are very easily confused. And I just got done teaching the 6th grade. The problem is, in all the years I've been teaching this stuff, my students get them so confused that it costs them their grade. It's common sense if you literally think about what it's asking. I always tell the story that the school that I came from a long time ago, the math teacher there switched the two on accident. Like, the teacher was teaching and accidentally got the two confused herself. So if the teacher can get it confused, can students easily get them confused? Absolutely. So if you're that person, it's normal. You know what I'm saying? But what I need you to focus on, let me zoom in just a tad bit more, is what it's saying here. Okay, now y'all learned, Joseph, y'all learned what factors are. Okay? Factors are the numbers that go into a number. Like, if it's 10, the factors are 1, 2, 5, and 10. Okay? That's factors. You've got to remember that. Multiples of 10 would be 10, 20, 30, etc. The next thing we learn is least common multiple. So do you see how you've got to have the difference between multiples and factors down? Okay? Multiples you can remember by multiply. 10 times 1, 10 times 2, 10 times 3, etc. Factors, we're talking about division, okay? What numbers can go into it. And with greatest common factor, you're looking for the biggest number that several numbers have in common, okay? Greatest common factor, GCF. It is the largest number that can be divided into the given numbers. I had a student help me write that. They said that's the way a kid's brain works. The largest number that can be divided into the given numbers.
They're right.
For example, I'm going to let y'all write that. Let's say I want to find the GCF of 12 and 18. Okay, so put your hand down. First, let's write out all the factors of 12. So raise your hand and you tell me one. One. I was writing to see. Okay. Joseph. 2. Kelly.
7. I'm 6.
Okay, 6. Let's go in order though.
Oh.
So we can say 6. I'll put that right here. Tanner. 3. Atalia. 4.
No, wait, no.
Wait.
Tanner.
Oh, wait, never mind.
Oh.
Atalia. 12. Ask yourself, 1 can go in there how many times? 12 times. 2 can go in there how many times? Oh yeah, 6. Now, here's the thing. I'm not going to mark it wrong if they're not in order, but it helps. Okay, so 18. Atalia. 1. Kelly.
3. No.
Can 3 go in there?
Yes.
Yes, it can. Tanner?
2.
2. Atalia?
6.
6. Joseph? 9. Atalia? 18. When you list them in order like that, you can see which ones do they have in common. All of them. What? All of them. Talia.
1, 2, 3, and 6.
They have 1, 2, 3, and 6. Do y'all see that? Kelly, do you see it? But we're looking for the greatest number that they have in common. So these are all numbers that they have in common. These are factors. These are all factors that they have in common. Remember, we listed factors of each number. We are listing or circling the ones they have in common, but we want to look for the greatest. So raise your hand. What's the largest one they have in common, Tanner?
6.
6. So the greatest common factor of these two numbers is 6. Yes?
Whenever we're doing like the actual worksheet, do we have to write it out if we already know what the answer is?
Just hold your horses on that one. All right. Any questions on that? Now we understand greatest common factor, but I guarantee in 30 minutes you'll forget.
You sure?
I'm pretty sure. All right. Do you think that all of your numbers are going to be nice, neat little numbers like that?
Maybe like 100 and something.
They're not going to be in pre-algebra. Therefore, to list all the factors of these big numbers would be near impossible. So, we use prime factorization to find the GCF.
What's prime factorization?
That, my friend, is the factor tree.
Oh.
So, step 1, write the prime factorization for each number. And even in my notes, I have factor tree.
It's not hard. I just don't like it. What do they mean by
See, what's funny is I love it. What, dear?
What do they mean by that? Like,
Remember how we did the factor tree and then you wrote out your factors with the multiplication sign, and if there were 2 prime numbers, you would do like squared or something like
but
that.
how would you figure out what the largest number is?
Girlfriend, I have not taught you that yet. We're still on step 1. Do the factor tree.
I mean, it's okay. It's not the worst. But
2. I would rather do factor trees all day long than solve a word problem.
oh, yeah. That's true. That's no brainer. But still.
All right, some people disagree. All right, step 2, identify the prime factors. Are these all prime factors? No. This is not prime. 4 is not prime. 9's not prime. 12's not prime. These are factors. These are factors of the number. We're looking for prime factors. So identify the prime factors common to all the given numbers. So identify the prime factors, so prime factors, that are in common to all the given numbers. Kind of like what we did up here. We found, but this was just factors. We found all the common factors. For step 2, you're finding all the common prime factors. Blah, 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 blah. And then step 3, find the product. What does product mean? You say that every time.
I meant multiplication.
Multiplication. I'm going to put parentheses and dot of the common prime factors. Okay, so once you find all the common factors, you're going to multiply them all.
Whoa.
When you have that down, put your pencil down so I know that you have written it all out.
I know this multiplication, I just said the wrong thing. Never done.
Alright. I'm running out of room, so I'm turning the page. Alright. Example. Find the GCF of 24 and 36. Alright, we're going to do it the right way. Step 1 is do a factor tree of both. So write that down. Joseph, what two numbers when multiplied give me 24? 8 times 3. Is 8 prime?
No.
So I'm going to continue. Is 3 prime?
Yes.
So I circle it. What two numbers give me 8?
2 and 4.
2 times 4. Is 2 prime?
Yes.
I circle it. Is 4 prime?
No.
I keep going. And then we have 2 times 2. And they're both prime, so I circle. All right, let's move over here to 36 before I write this out. Atalia?
12 and 3.
12 times 3. Is 12 prime?
No.
Is 3 prime?
Yes.
So I circle it. What two numbers give me 12?
4 and 3.
4 times 3. 4 prime?
No.
Keep going. 3 prime?
Yes.
Circle. And we know 2 times 2. And they're both prime. Yeah, I'll let y'all catch up. Make sure you're circling. Tanner, wake up. All right. Now I'm writing my prime factorization underneath. Boys and girls, you write the prime factors. Remember, these are the prime factors. You write them in order from least to greatest. And we cross it out. So here we go. 2 times 2 times 2 times 3.
Or 2 to the third power.
No, we're not doing that right now. You don't write it in exponential form right now. All right. And then this one. Remember to cross it out when you write it. 2 times 2 times 3 times 3. Make sure you have that.
I have a question.
Mm-hmm.
Is it asking for greatest common factor or greatest prime common factor? Greatest.
You'll see. It's greatest common factor. Now we circle the ones they have in common.
3 and 3.
You could do these two, but I always do this to show that you can go diagonally. They don't have to be right on top of each
We
other.
also do the 2 together too.
Yeah, you could also do that pair, but you're looking for pairs, okay? You're looking for pairs. Do you understand that? Now, you're going to bring down 1 from each pair. So look here. I circled a pair. I'm bringing 1 down. Times. I circled a pair here. I'm bringing only 1 down. I'm not bringing 2 from each. You see that? I'm only bringing 1 from each. And then here's a pair of 3s. Yes? Okay, does everyone see that I'm only bringing 1 from each pair down? All right, so what's 2 times 2 times 3? Natalia? So the greatest common factor for 24 and 36 is 12. So 12 is not prime, so it's the largest number that they both have in common that goes into both. Any questions?
I see it.
Any questions? She sees it.
What's it?
I don't know. All right, any questions? All right, let's do another example. 180 and 600. Tanner,
Can I sum it?
tell me what 2 numbers give me 180 when multiplied.
10 and 18.
Very good. 10 times 18. Good job. Is 10 prime? Nope. Is 18 prime? So what 2 numbers when multiplied give me 10?
2, 5.
2 times 5. Is 2 prime? Is 5 prime? So I'm circling them. Good job, Tanner. 18. What 2 numbers give me 18?
7. No, 9 and 2.
9 times 2. Is 9 prime?
No.
Is 2 prime?
Yes.
Circle. And then what 2 numbers give me 9?
3 and 3.
And they're both, so I circle them. Y'all see that? Good job, Tanner. All right. So, Kelly, you want to do 600? All right. What 2 numbers give me 600 when multiplied?
300 times 2.
300 times 2. Is 300 prime?
No.
Is 2 prime?
Yes.
All right. What 2 numbers give me 300?
150.
150 and what?
Times 2.
All right.
Sorry, it took me like a hot moment.
All right. So 2 is prime. 150 is not.
That's a long road. Okay. I'm just gonna divide it by like 2. Hold on, 1 second.
Uh-huh.
Okay. This is fine. Seven.
2 goes in there 7
Sorry, no,
times.
sorry. No, I was thinking out loud for a second. I'm sorry. Hold on. Just give me 1 second. 75 times 2.
All right. That sounds better.
Sorry, I was speaking out loud.
All right. So 2 is prime. 75 is not.
I regret doing this. Okay.
She's fine.
Times 3.
3 times 25. Think of it as quarters. 75 cents. How many quarters are in 75 cents? There's 3. Yeah. All right. How about 25?
5 times 5.
Very good. Okay, so now we're going to write out our prime factors. And we cross them out to make sure we don't leave anything out. So 2 times 2 times 3 times 3 times 5. And then over here I have 2 times 2 times 2. See how you could, if you cross them out and circle, you can easily keep track of them. Okay. So, what do we have in common? Tanner?
2, 2, 3 and 3, and 5 and 5.
Wait. I have 3. Where's the other? We only have 1 3 over here, and there's 2 up here, so I only have 1 pair. See?
I meant like 3 and 3.
Oh, I got what you're saying. Okay. Okay, and then, yes. All right, so we take 1 of each. I have 2 times 2 times 3 times 5. Raise your hand. Natalia?
So I'll solve it?
Yeah.
60.
60 is the greatest common factor. See, just by looking at 180 and 600, you would not know that 60 would be it. Okay? That's why we do prime factorization.
Sorry.
That's okay. Any questions?
Yeah.
What?
Is there any way that we don't have to do all this if we do know the answer, like before we solve it?
If you can look at it and figure it out, go for it. But if I circle 1 homework problem, guess what you have to do?
I have to solve it out.
That's right. If there
I just take rid of the zeros.
are no common factors, the GCF is 1. So if you listed all these prime factors and they have nothing in common, then the GCF is 1.
Well, what if it's a negative number?
Negative number? We don't deal with negative right here. So for example, let's do 9 and 16. 9 is 3 times 3, right? 16, we can do 4 times 4, which is 2 times 2, and 2 times 2. Just by looking at these, do they have any prime factors in common? Kelly, do you see that?
Yes, I am.
See, 9 has just 3s, and 16 has just 2s. They have nothing in common, so the GCF is 1.
Not too bad.
No. Okay, we're going to stop here, and then after lunch, y'all come here. Guys, come right in here, and then so we can finish up.
What if you're not in here? Like,
Oh, I'll be here.
okay. Oh, I was not thinking of the factor. I was thinking